Now we're going to look at a summation notation. This might be something that you've seen before, but this might be something totally brand new. The nice thing is it's not anything too tough. So we've got this expression here that looks kind of crazy, but there is a lot of information packed into this sort of small package here. So first off, this big sort of E looking thing, this is a sigma. It's a Greek letter, it's a capital S. And knowing that it's a capital S and that we're calling it summation notation, this is telling us to add. So sigma, capital X, means for us to sum, so we're going to add. Now, what we're going to add is a bunch of things where we evaluate this 3 times k plus 2 for different numbers. So the numbers we're going to evaluate for, we're going to start at 1 here, and in this case, or so we'll say it, maybe say it a slightly different way. We're going to start at this bottom number because sometimes it's 1, sometimes it's 0. It could be any number. You can start with any integer that you want. And we're going to stop at the top number. And again, this top number can be all sorts of different things. And actually, if you go on in math, you'll see times where, and actually we're going to see this, I forgot about this. We will see this where that top number is infinity. So that could be an actual number, or it could be something like infinity that we can actually have our sum go forever. But when we're plugging these numbers in, so it's going to tell us we're going to start, this one's telling us we're going to start by plugging in 1, we're going to stop when we plug in 5, and we're going to go up in increments of 1. So we're going to increase each time by 1 until we get to our top number. So this is telling us that we need to plug in 1 for k. So starting at 1, again, that 1 comes from that k is equal to 1. And we need to plug in 1, and then we're going to go up by increments of 1. So we're going to go to plugging in 2. We're going to plug in 3. I don't have enough room on this one line. We're going to plug in 4. We're going to keep going until we get to this top number up here, which is 5, and that's when we're going to stop. So this is telling us, this sigma notation is telling us to add up what we get from plugging 1, 2, 3, 4, and 5 into this expression, 3k plus 2. So plug each of those numbers in and then add up what you get. So really this is mostly a lot of arithmetic. You know, when we plug in 1, we get 5. When we plug in 2, we get 8. When we plug in 3, we get 11. 14 and then 17. So again, where those numbers are coming from is they're literally, what we get from doing this little bit of arithmetic. 8, 11, 14, and 17. And when we add them up, we get 55. So overall, our answer is that the sum starting at 1 going to 5 of 3k plus 2 is 55. And there's all sorts of wonderful things that we can do with this sigma notation. Most of these are not going to be necessarily the most important for us right now. A couple of them I wanted to make sure that I clarified what they mean. So this first one is we've got I equaling 1 to n, and again up here I used k. We can use whatever variable down here as our index. That's what that's called, is the index. We can use whatever we want. A lot of times use I, K, or J. Those are kind of the standard ones. Sometimes we use N down there. It kind of just depends. So this is saying we've got the sum of a constant. So what this would look like, for reals is if maybe we had I equaling 1 to 4 of 7. So there's no variable there, so it's saying to add that constant term 1, 2, 3, 4 times. So we've got, let me grab a different color. That's plugging in 1, plugging in 2, plugging in 3, plugging in 4. Because it's a constant, we get the same thing no matter what we plug in, and so it's telling us to start at 1, go all the way till we get to 4. That's 4 of them. So we end up with 4 times 7, which is 28, which is what this is telling us. It's that number on top times our constant. And the second one says, all right, if we've got a multiple of our term there, so C times A sub I, again, what that means is if we're doing some sort of sum like I equaling 1 to 3 of 5 times I, now this would be 5 times 1 plus 5 times 2 plus 5 times 3. We could factor that 5 out and get 1 plus 2 plus 3. So that's really all this is telling us, is that you can factor that constant term out and you get the same thing if you do 5 times 6, which gives you 30, as if we did each of these individual multiplications, plus 10, plus 15, we still get 30. So it's telling you get the same thing either way. 3 and 4 are saying if you've got two different terms in there that are being added, you can split up those summations as the sum of the first plus the sum of the second. Same with subtraction. And this last one is a little bit interesting because it's basically telling you that you can take your summation and maybe do something like the first half of it and then the second half. This is not a trick that we're going to use often in this class. It's something that we would do if you were taking maybe Math 253, but it is something that you can do. So the idea is if you've got, the sum from 1 to maybe 100 of something, you can split this up and go from 1 to, we can make this number that we end at here whatever we want. So we could split this up to be any number. We can kind of make this split. So this could be any number between basically 2 and it would have to be like 98. So we could do this however we wanted. We could break up this sum and split it into two different sums, however we wanted. Like I said, though, this is not really a trick that we're going to use, and I do call this a trick because this is a little bit of a trick, even though this is true. But it's not something that we're going to use a lot here. But these are good to kind of to look at and think about. So again, I hope that you're noticing that this really is as easy as you think it is, that we're just plugging integers into this expression that they give us. So here they give us 2n squared minus n, and here we're going to start at 2 and we're going to end at 6. And really, literally all we need to do is plug in 2 and then plug in 3. Got to be really careful, especially when you've got that variable in there twice. Plug in 4, and then I wrote too big. Plug in 5, and plug in 6. And then see what our sum is. So from, again, this first expression here, we get 6. From the second one, we get 15. From this one, we get 28. From this one, we get 45. And from this one, we get not 36. We get 36 times 2 minus 6, which is 66. So we get 6 plus 15 plus 28 plus 45 plus 66. So our sum is equal to 160. So we can write that up here if we want as well.